Sylvia and to Marcella for being here, and to the other members of the organizing committee. Thank you for the introduction too, Sylvia. I'm going to just start off maybe by saying a little bit more about my background, just to set some context. So for many years I've been studying developers, developer productivity, trying to understand how to improve their experience, how to improve the tools and the processes that they use. This is some of the work that I did with colleagues at Microsoft. So as Sylvia said, I am spending time in the university, but also working closely with companies as well, and trying to really ensure that the research that we do has an impact on developers. So closely studying developers. We had a wonderful keynote yesterday from Natalia, and this is a little related to what Natalia was talking about yesterday. This is another way of looking at the kinds of research that we do. This is a paper called the Who, What, How framework for thinking about socio-technical aspects of software development. And so in this framework, we talk about who our research is going to affect. Are we trying to improve the tools, or are we trying to actually improve the lives of developers? Or are we trying to create researchers? And then the what that I'll talk about a little bit more maybe later on is, are we interested in studying the problem space, or are we interested in building a solution and evaluating that solution? And then finally, the different strategies that we can use for evaluating our research. I use this framework because I look at the particular strategies that really focus on directly observing developers, okay? So for example, observing them, interviewing them, or surveying them, rather than mining data from repositories, which is human behavioral data, but it is somehow indirect. So we focus a lot on trying to study developers and really understand their experience. But what I'm going to talk about today, as I mentioned, I've spent many years trying to understand developers, trying to improve their lives, trying to improve the tools that they use, and of course now we have this Gen AI thing. So, for me as a researcher for many years, looking at the tools that developers use, this is a pretty exciting time, because for several years, not a lot changed all that much, and now we have this huge disruption, right, on how developers are working. Anybody here heard of Kent Beck? He's probably one of the most famous people in software engineering. He developed a lot of the agile stuff and refactoring. He's known for test-driven development. And I was hosting a talk by him last week by the ACM. And before he went live, he was telling me how he's been doing vibe programming, which is this sort of experience of chatting with the AI agent and not writing any lines of code, just through chat. And for Kent Beck, who's one of the best programmers in the world, to say he is having the most fun in his life doing vibe programming, you have to pay attention, right? So there are these big changes coming. And I will say that AI measurement is a bit of a mess. We've heard this from other folks that are looking at the way that AI is being used, not just in development, but in other areas as well. So this was an article last year in the New York Times in 2024, where this author said that it's just a tangle of sloppy tests. And this is not surprising, really, when we think about the pace at which AI is being adopted and changing overnight. The tools are changing, the techniques are changing. And so people in industry and academia, we are rushing, right, to catch up with this. And industry is in this position where they have to move really fast. So this is a quote actually by a former student of mine, Peter Rigby, who's now a professor, but he also works at Meta. And he gave a really great talk at our university a few weeks ago. And he was showing us all of the tools that they're developing and how these tools are rapidly changing. And the way that they evaluate their tools is they do A/B testing, right? They're Meta, after all. So they create a new tool, they release it to their developers, and then they see whether the developers adopt it and how they use it. And that's how they decide version B is better than version A. What's lacking a little bit in that process is that we may know that version B is better than version A of a particular tool, but we don't have a good understanding, a good theoretical understanding about why one tool is better than the other. And he said this in his talk. He said, there's such cool stuff going on here, but we have to move fast. We have to create the next version, release it, collect the data, and decide which tool we're going to release to our developers, because Meta, as you may know, one of their mottos is move fast and break stuff, right? They want to move fast. So this is a great, honestly, opportunity for us in academia, because in a way we may feel like we're running behind industry in developing these tools and the models, but they don't have the time to do the deep kind of understanding of how these tools are being used. So this is a great opportunity, I think, for people in academia to really pause and really look deeply at what it is that these tools are offering. And I will say that most of the studies, and I'm going to present some studies today from academia, but most of the ones that are on Gen AI are from industry. And most of them focus on measuring things like development speed, code quality, of course, and tool satisfaction. So pretty kind of high-level things, really, in a way, right? And so what I think we need to do is leverage and extend foundational human-centric theories that outlive the tools, right? So yesterday it was, Copilot, tomorrow it's going to be something else. It's by programming today, agentic AI, God knows what it's going to be in a few weeks. But our foundational human theories may hopefully last a bit longer. And we can also use these theories to aggregate our findings across the different studies that we're doing as well. So a lot of the results that we have coming out from our academic research are often not connected to each other. That there's a lot of systematic literature reviews out there that attempt to do that, but often they also don't really relate the findings that much in terms of human-centric aspects. So when I was thinking about preparing this talk and thinking about, well, which human level or human-centric theory should I try to present, I was struggling, well, which of these, which lenses to choose to look at human-centric aspects. And I got some inspiration, actually, in an unusual place. So I teach a course on startup programming with a colleague from business, and she invited me to this young entrepreneurship event at a local shopping center. And these children were tasked with being entrepreneurs from a very young age, and to create their art and to think about what they could create that other people would want to buy, right? So they had this goal, right? They were to be creative, but they had this goal of making money and a constraint of making money, right? So it wasn't enough, to get mom and dad to buy all the materials, but they had to, sort of do a budget and decide, can they actually make money, make this thing, and then make something that people want, and then sell it to them. And many of the children, so I walked around this shopping center and bought probably way too many things because they were all so cute and adorable. But many of the children, they worked together, so they collaborated with each other, and that's where some of that magic happens, right? We know that as researchers, we have magic happening here right now, right, at this conference, because that working together really amplifies our creativity and our cognition, right? And the entrepreneurship for kids invokes what's known as in psychology as creative problem solving. So this is different from being creative, where you don't necessarily have a concrete goal, right? So they had a concrete goal of making something that people want, right? And it's different from problem solving, where there is a clear solution. So creative problem solving is you have a problem, but there are many different ways to solve that problem. And this reminded me as I was walking around, I'm like, this is development. This is software development. We're always creatively problem solving, right? There's a problem, a need that we need to fill, but there are many, many different ways to do that, right? And as I was also walking around and looking at all of the things that the children made, I realized that it's really important to look beyond their art and to really see the children behind that, right? And it's the same with development, right? Looking at beyond the code, the systems that they use, and really focusing on the developers. And part of the lenses that I'm going to talk about, I was thinking about these as I was walking around. When children create art, I'm sure there's some people here in the room that have children, or you were a child yourself, you remember making art and being really embedded in that experience, that optimal experience of making that art. So I'm going to talk about flow experience today. And then the tools. Actually, some of the kids were using 3D printers. That's pretty amazing, right, for making their art. The tools augment their capabilities, right, to support their creative problem solving. So I'm going to talk about how tools augment our human capabilities. And then the third piece that I've already kind of hinted at is this collaboration aspect. How collaboration enhances our experience and the children's experience and our creative problem solving activities. So these are the three lenses. So I'm not going to keep talking about the children and entrepreneurship, I promise, for the rest of the talk. I'm going to switch to talking about software developers. And I'm going to use these three lenses of flow experience, cognitive augmentation, and collaboration to really think about and to push forward into how Gen AI may support creative problem solving and software development. And for each of these lenses, I'm going to talk about what the theories are that we may consider. They're not all of the theories, there are other theories, I had to pick and choose some. I was a little greedy, I picked quite a few, so I hope you had some good coffee because I'm going to go pretty fast through some of these. And I'm going to talk about what we know already in terms of these theories in software development before Gen AI splashed onto the scene. And then I'm going to sort of think about how could we use those theories to explore how Gen AI is being used. I should also say that this talk isn't really a summary of my previous work so much as I'm looking forward. So I have some ideas for research projects or research questions that we could answer. So I'm looking forward a little bit in this talk. I'll have a couple of connections to my prior work, but not a lot. So the first one that I want to talk about is flow experience. How many people know about this theory of flow? Yeah, a few people. So yeah, this is something that we all experience. CibSE was a psychologist back in 80s and 90s, and he wrote this book called Flow, The Psychology of Optimal Experience. He recognized that when people get engaged in tasks, when they're intensely concentrating on a particular task, that they have this flow, this optimal experience. We've all had that, right? Whether it's playing music, playing sport, developing, we've all had those flow experience where we feel this merging of action and awareness happening. We can't really differentiate what we're doing from our awareness of what we're doing. We lose self-consciousness. We forget that there are other people. My husband is in the room today. He has experienced me developing, and he's walked into the office, and I haven't even noticed he's there. Sorry. We lose control. We have a very strong sense of control over our actions. Sometimes that sense of control is not warranted. So people who climb, for example, they have a sense of control over their actions. Or if you're a sailor, you feel like you're in control. You're actually not. We're never really in control as humans. But we feel that, and that is part of that flow experience. We have a distorted temporal experience, so we may keep programming till 2 or 3 o'clock in the morning and not even notice, that it's so late. And we also have what's called an autotelic experience. So the activity itself is intrinsically rewarding. We enjoy that activity. And many years ago, actually probably in 2003, I started looking at this flow experience in terms of developers, and I've been fascinated by this kind of theory and how it relates to software development. But these are the characteristics. CibSE also talks about what are the conditions so that you have these flow experiences. So it's very important that there is a balance between your skill and the challenge that's set for you. Anybody playing music here? Music is always our sport. If when you're playing a piece of music, it's too hard, you're not in flow. If it's too easy, you're not in flow. You need to have that balance between your skill and the challenge. And as you get better at something, then you start to play harder pieces, right? So then that balance keeps moving along. You also need to have clear proximal goals. So I was mentioning that example of somebody climbing up a cliff. They're not looking at the very top, right? They're looking at where is their next foothold, where's the next thing that they're grabbing. And by seeing that, those close goals keep them in that flow experience. And they also need immediate feedback. They need feedback that what they're doing is actually getting them towards those goals. So And actually, I'll also put in here about this notion of collective flow. So Csikszentmihalyi talks about team flow as well in his book, and some folks have done some research after that. And one of the interesting results on team flow is that our beliefs in what we are able to do positively predict our collective flow over time. So when we're part of a team, if we believe we can succeed, we are going to more likely get in that flow experience, and then that is also going to increase our belief that we can do the task. And what happens when we achieve flow? Well, we feel joy, right? We feel happy. That's why Csikszentmihalyi called it this optimal experience. And it enhances our creativity. So we are more creative, we do more cool stuff, we learn better, and we're motivated to do our task. And we reach out that peak performance as well. So there have been quite a few studies about flow in software development. I put pre-gen AI here because most of these studies are before generative AI splashed onto the scene. And many of these studies really focused on the barriers that developers feel. And these barriers may be personal, interpersonal, how we relate with other people, or situational, related to our environment or the tools that we're using. So many of the studies actually focus on interruptions, so other developers interrupting each other, distractions, maybe having to switch a task and then having to recover from context switching, as well as insufficient time for focus, for creativity and for learning. So developers actually only have about 10% of their time is focus time when they're working in a company. And there's been a little bit of research on interventions, not so much to improve these experiences, to remove interruptions, to block distractions. There's also been some research on friction of the tools that developers use. So they're difficult to use, they're difficult to install, or there may be friction introduced because of security issues, stopping them. We had that today, Sylvia. You were trying to log in and you had all these security things. So that's that example of friction getting in the way. And waiting on others, getting stuck. So software development is a collaborative experience. So I may get blocked waiting for somebody else to review my code, or I may be blocked on somebody else finishing a piece of an API that I need to use. Janumi is one of the few people that looked at this kind of challenge aspect, that there may not be enough challenge or there may be too much challenge. Spoiler alert, I'm going to get into Gen AI about that, right? What is Gen AI doing to that challenge piece? And then there's been just a couple of studies that have looked at enablers. So the studies that I just mentioned were the barriers to flow. These ones looked at enablers, the importance of goal setting to facilitate flow in software engineering. So Andre Meyer looked at how developers can set goals and how the tools support them in setting goals, how that's important for achieving flow. And then fast feedback also facilitates flow in software engineering. So I did a study with some folks at GetDX, and we noticed as from the analysis of our data that feedback, how quickly developers were getting feedback, had an impact on their flow experience as well. But if I looked at that body of research, and maybe I missed one or two studies, most of the studies focused on the barriers to getting in flow, and not very many focused on the conditions to getting in flow. My student, Arnie Starr, is developing a new theory of flow. I thought I'd mention this here. She has a tool called Flow Insight, which is about creating some of those conditions for flow. And her theory of flow, she looks at two sides of flow. So there's troubleshooting side and there's momentum. So developers spend a lot of time troubleshooting, trying to understand how the code works, or trying to get help from other people. And then once they get that help, then they can start building momentum towards getting in flow. So that momentum building is really important. The studies that we have from industry looking at Gen AI, so most of the studies so far on flow and the impact of Gen AI and flow are coming from industry settings. I don't have them all here, but I'll include a few. So McKinsey, they ask questions, you know, how does using Gen AI affect how happy you feel? Does it support you in doing work that makes you feel impactful, that you are doing impactful work? And were you in a flow state? And you'll see that people were more likely to be in flow state and happier using Gen AI. My colleague and former student, Rini Kaliamvaku at GitHub, used the space framework that I just flashed up at the beginning to look also at how the impact of Gen AI on flow. And she found that developers who were using Copilot were more productive, they felt more satisfied while they were using Copilot. And in terms of efficiency and flow, they were having faster completion, they were more in flow, so very kind of overarching concept there. And they spent less time searching and less mental effort on repetitive tasks. A couple of other studies, so my colleagues at Microsoft, they also found that 88% of their users there using GitHub Copilot, they reported doing more fun work and less time writing out tedious boilerplate code. At Meta, I mentioned Meta at the beginning, and my student Peter Rigby there doing work on looking at multi-line recommendations. And one of the things, they didn't look deeply at the human aspects here, but they did notice that when they had a recommendation, the tool made a recommendation that was many lines long, it interrupted the developers, right? It broke their flow. And so they reduced it to just a couple of lines at a time to keep developers in flow. And then there's this thesis from academia. This is a master's thesis. It's a small study, I think interviewed with 12 developers, and they noticed that AI helps developers, some developers get in flow, but it may cause others to get stuck if there's a lack of that task context. This is not a study, but this actually came in my email a couple of days ago from a colleague of mine. He got an email from a student saying, you know, I'm using ChatGPT while I'm coding away, and I'm just not having as much fun as I used to have. He said he's finding their way of programming now is a lot of prompt engineering, it's less satisfying, it's more dull, and it's less likely to put them in flow. So this student is a very good programmer, and they found that Gen AI was actually not more fun in contrast to some of the findings that were coming out in the other studies. And they found that they were less productive because they couldn't force themselves to stay focused on the task. So that motivation piece was kind of lacking because of the use of Gen AI. And so when we think about flow, and the essential conditions for flow, this balance between skill and challenge, the clear proximal goals, and that immediate feedback, if we look at the other studies, they're not really focusing on those essential aspects. Actually, I reread Csikszentmihalyi again the other day, and he doesn't talk about things like interruptions. He talks more about these things, and yet our studies are kind of focusing on more the barriers and not about the essential conditions for flow. So looking forward, I think we need research that helps us explore how generative AI or large language models can help set these conditions for flow, so that when developers are working with these tools, that their skill and the challenge that's set for them is being matched, and they are getting feedback on their goals, and they are getting they are also seeing how their progress is going as well. So this is kind of my call for more research on this. All right, so that was the first lens, flow experience. The second lens that I want to look at is cognitive augmentation. I should have mentioned at the beginning that many of these theories that I'm talking about, some come from psychology and others come from human-computer interaction. So hopefully some of you here may know some of them, but hopefully there's something new here for everybody. So with cognitive augmentation, there are theories about how technology or how tools can help augment or increase our capabilities as humans in terms of how we think, right, and reason and learn. And I'm going to go through 3 different theories here. The laws of media by McLuhan, cognitive support theories, which I'm guessing nobody in the audience probably knows that one. And I'm also going to talk about cognitive augmentation, which is an older theory that maybe some of you have heard about, but somehow we don't think about it so much anymore, and I think we need to go back and think about that theory. Let me start with the laws of media. So Marshall McLuhan is a Canadian, was a Canadian, he died in the 80s, and a lot of his research he did in the 70s and 80s, and he noticed, he was a media scholar, so his research was looking at new forms of media. Now, by media, he meant any technology that humans use. So a car was a form of media to Marshall McLuhan. Clothing was a form of media. So anything that kind of enhanced our capabilities is media. And he noticed, I mean, this was the time when, well, the internet wasn't even quite there, but he had noticed, printing. And what he noticed is that when we have a new form of media, that it enhances our capability as a human. So for example, the car helps us go faster. At the same time, it makes obsolete or less frequently used another form of media. So with the car, it made obsolete the horse and cart. It also retrieves something. So this is the harder part for a lot of us to understand. It brings back something from the past that was made obsolete before and brings it forward and makes it relevant. So with the car, it brought back this idea of a knight with their shining armor, right, on a horse. And when it's overused, when it's used to an extreme, it reverses the very thing that it was sort of designed to support. So for example, with cars, they help us go faster, but when there's too many cars, we go slower, right? And it's actually faster to walk sometimes. And so that forces a reversal or a flipping in to some other new technology to address the problems that media has created. Anybody here heard of Stack Overflow? Right. So Stack Overflow. So in this paper, I have a link to it here. We use McLuhan as part of this research playbook for understanding disruptive technologies in software development. And we look at Marshall McLuhan, we use Marshall McLuhan's tetrad of the 4 laws to think about how Stack Overflow, what it enhances, what it makes obsolete, and so on. So Stack Overflow enhances our ability to get fast answers to questions, right? We can quickly go there and get those answers. It helps us with debugging, so developers often take their stack trace and put it into Google, which then brings them to Stack Overflow and gives them insight, answers to questions about that stack trace. And it also builds community. So we see communities building around different threads and different strands of Stack Overflow around different technologies. What did Stack Overflow make obsolete or make less common? Well, email. So many open source communities before Stack Overflow came along, used email to share information, to ask questions and answer questions from each other in the community. And so what we saw when Stack Overflow was being adopted by these communities, that email was being replaced in many of them by using Stack Overflow. People were shifting there. It also made obsolete some documentation. So I remember when Stack Overflow first came out that I was speaking to some developers in a company, and he said, we don't create documentation anymore. We just, use Stack Overflow. And if I get an email or I see an email about a question, a technical question, I'll go and search on Stack Overflow, and if there's no answer, I'll add it there. So that when somebody else looks for it again, they'll find it. Excuse me. It also, to a certain extent, was making some textbooks obsolete, as well as onboarding documentation. What does it retrieve? So I said retrieve is kind of the hardest one because it requires a deep understanding of the technology and the users to really understand what it brings back from before. And this did take us some time to think about this. So what we saw with Stack Overflow, again, I'm showing my age here in some of this because I've been around for a couple of decades in studying development. It brings back this notion of gurus, which were in the early days, like Brian Kernighan, the early days of C and Unix. There were these famous people that knew all this stuff. And Stack Overflow brought that kind of back again because they were the folks that had the highest number of score in Stack Overflow. And they were known, they were very well known in their community. And it also brought back this notion of portfolios, so a lot of developers got jobs by pointing to the kinds of questions that they were answering on Stack Overflow, and people were voting them up, showing that they were technically competent, and they would get jobs from that. Well, what did Stack Overflow reverse into? Any ideas? When it was overused? Any thoughts? Well, I'm going to put this forward. Well, first of all, it reversed trust. So as more and more answers came in Stack Overflow, we saw the best answers being diluted. And people started to upvote wrong answers. And so our ability to kind of, in the earlier days of Stack Overflow, it was actually better. The quality of the answers was better. Anybody notice that with Google as well in the last few years? It used to work better, right? And then it started giving us all this stuff, right? So it reverses our trust. And with development, instead of improving the quality of of the way that we were using the information in Stack Overflow. I saw my students do this. They would bring their code to my office hour, and I would say, what's this? Oh, I copied it from Stack Overflow. I was like, what? Right? So this blind hacking, it kind of undid what it was trying to do. And I think in some sense, Stack Overflow and this, the challenge of customizing the answers in it for development tasks actually caused this, in part, this flipping into a need for using large language AI. Because generative AI is now, it's being fed, right, by all of the data in Stack Overflow, but it's taking it in a way that is customizing it for a particular programming challenge. So that's looking at how that is being flipped into. So what about AI? So what about applying McLuhan's tetra to generative AI? So with Sylvia, actually, and a bunch of other folks, we use this tetra to try to think about what is generative AI enhancing, making obsolete, retrieving, and reversing into. And we have a long list. Okay, I won't go through all of these, but obviously lots of automation possibilities, lots of quality improvement possibilities, personalized solutions. I mentioned that from Stack Overflow. Documentation, code reviews. We can use generative AI to generate our documentation, to even do our code review for us, or to assist in our code review. And it is also potentially increasing our creativity, potentially, right? We're seeing some signs of that as well. In terms of what it makes obsolete, well, Stack Overflow is not being used as much by developers these days. They're turning instead to ChatGPT and Copilot and Claude. But it's also lowering barriers to entry for a lot of people who didn't really code before to be able to use these tools and now to be able to create software. So it's lowering those. I saw that in my startup programming class with the students that were not from computer science, they were from business, that they were able to use tools like ChatGPT and Claude to actually generate early versions of their code, which we hadn't seen before. It maybe also makes obsolete a little bit this nerd culture that we saw happening with Stack Overflow. So I mentioned the gurus, but a lot of it was kind of a little bit on the nerdy side. And that deep sort of technical knowledge about the APIs or particular programming languages is now perhaps not appreciated as much anymore because the answers are there, right, on ChatGPT. It maybe is also making obsolete traditional education and maybe onboarding support. I don't know, that's what we had in our paper, but maybe that's something to consider in a different way. And then in terms of retrieval, well, it brings back, so when I learned how to program, again, I'm showing how long I've been around, but I used to write out the algorithm in pseudocode. I'd write it out in English. It kind of went out of fashion for a while. But I'd write out what I was trying to do in English, in natural language, and then I would translate that into programming language. And that's what's happening with using generative AI, that developers are now thinking in natural language, and they're writing what they want the software to do through prompts in natural language. Chatbots were also super popular in the early 90s. And then they went out of fashion for a while. AI agents too, the AI cycle of hype, there was an early version and now there's generative AI. So we see AI agents coming back and also more focus on end users as programmers. But we also see things like ethical and privacy concerns coming back as well, which maybe we weren't so concerned with for a while. And then in terms of, well, what does it reverse into? Well, we're seeing this over-reliance on it. We're potentially seeing homogeneous solutions. So ChatGPT kind of creates this bland kind of, aggregate version of, the mainstream stuff that's out there, which may not be the best, may not be the most elegant solution. We're seeing maybe more of a loss of control. So here I'm heading back to that flow. Remember, one of the conditions for flow was that feeling of control and feeling what's going on. So that loss of control is potentially going on. And low understanding, lost provenance of where things are coming from, and maybe lack of empathy for humans as well. What is generative AI going to flip into? What is the next thing? I don't know. I don't know. I don't have such a good imagination. I don't know that many of us really can think about, things are moving so fast, what is going to be 10 or 20 years from now?
But McLuhan's tetrad helps us think about some of these questions, and all of these things here are speculation. All of these are potentially open for research. And as I said, what will Gen AI reverse into when it's overused? And maybe we would focus on a particular task. These are many open questions. We're still not sure. All right, the second cognitive augmentation theory. So I'm still in the middle lens of cognitive augmentation, and I'm talking about 3 different theories here. The second one is called cognitive support theories. And it's about thinking about the tasks that we as humans do all the time, like searching, matching, pattern matching, recalling information, reasoning about something in order to make a decision, problem solving. And cognitive support tools, this is a theory by Wallenstein et al. Anybody hear of this theory? It actually it wasn't as popular as I would have thought. It's a really good theory. We've used it a lot in my group. It answers the question, what is it about IDEs, integrated development environments, that developers really, why is it that they work so well? Why do they adopt these tools? And these theories help sort of answer that question. And the theory asks us, what is hard about this task that the developer has to do, and how can this tool help? Okay? And so some of these cognitive support things are like having better visibility into what's going on, having more efficient navigation, having better abstraction aids. So development is all about creating abstractions. We're always creating different abstractions as we're writing code. So having better ways of seeing what are those abstractions and linking from one level to another, as well as what's called cognitive offloading. So anybody here good at doing long division in their heads? Of course, we use our phone these days. But if your phone ran out of battery and you had to do long division, you would probably use some paper, right? Even multiplication, you would use some paper. That is cognitive offloading. You're removing some of the need to remember intermediate results to the piece of paper. So that's what the cognitive support theories are about. And there's different types of cognitive support. So there's tools to support search, inference support, so showing dependencies. Again, that's one of the things about software development that makes it challenging, is keeping track of these dependencies in the code. Transformation support, so refactoring is an example of transforming something that's maybe messy into something that's a little bit more elegant. And then traceability support, so helping understand changes over time. So things like version control provide that traceability support. And then Wallenstein also talks a lot about how do we evaluate that cognitive support. So he talks a lot about the task artifact fit. So the artifact being the tool or the representation. How well does that actually fit with the task to be supported? And does it actually reduce cognitive cost, or does it overload your memory or attention in some way? So I'm sure we've all had experiences where we've used a new tool or a new version of a tool, and you've realized, wait a minute, this is actually making my life harder. I'm having to work harder to do this than I used to before. What the heck? It's because the people that designed it didn't evaluate it thinking in terms of cognitive cost. So how can we use these cognitive support theories to understanding the impact of generative AI? How is using generative AI, how are we going to, when we're generating our code through these prompts, how are we going to keep track of that traceability? How are we going to keep track of inferences of the dependencies between the code? And how does it support our cognitive cost, our cognitive fatigue? All right, the third one I want to talk about is really going back a little bit in time to something called cognitive augmentation. Anybody here heard of Douglas Engelbart? Yes, good, a couple of people. Anybody here know what a mouse is? Yes? So Douglas Engelbart, actually back in the early 60s, designed the mouse, this notion of direct manipulation. He also designed the early version of graphical user interfaces, as well as early version of the internet, networks, as well as even hypertext. And he really was a visionary, well ahead of his time. He realized way back then, remember this is in the 60s before anybody had a PC or a Mac, and he emphasized that computers should be about augmenting our human capabilities, not just about automating them, replacing them. And so thinking, learning, reasoning, these are all aspects of our human capabilities that should be augmented. And he proposed how technology can amplify our human intellect by improving our ability to comprehend complex problems, manipulate the information that we need to understand a problem, make decisions, or to collaborate and do problem solving creatively. By the way, my images were created by ChatGPT. It's kind of cool. I was thinking of children at the time when I created them. These were the kinds of ways that he thought computers should support people. I'm going to put out there that for a long time, they weren't doing that. They weren't really helping us do this deep level of thinking, this reasoning and manipulating our information, as well as he thought that we would be, doing it, say, until now. And he also predicted a co-evolution of humans and tools. So where our cognitive work is distributed between individual and external systems. So anybody here good at navigating these days without Google Maps? Right? We all use Google Maps, we all use Google. I'm thinking back to when the network is down and we can't Google for stuff because our brains have changed, right? Our brains have been rewired to use those tools. And he saw that back in the early 60s, that the way humans think in our brains, our wiring of our brains, would change as these tools were used. He also, anybody familiar with the notion of a GPT on top of ChatGPT? If not, let me just share this, but he was incredibly visionary. He had this idea that we were going to be able to build tools that would help us improve our tools. Very meta, right? And it's this recursive model for accelerating intellectual growth. And generative AI is a general purpose technology through which we can create other general purpose technologies to then improve the specific tools that we need. And there's already this notion you can, using natural language, you can create your own custom version of ChatGPT to be particular to a specific domain or task, to then give support for you that is specific to that. So he saw that. He saw that that was going to be possible. So how can we improve tools that help us improve tools, right? To augment developer intellect, but without forgetting that our goal is to improve human intellect. Because often in software engineering, we get attracted by the shiny tool and we forget about the developer that we're trying to support. So that's why I put that part in there. I'm going to sneak in one other thing. Engelbart also influenced ongoing ideas today about human-AI collaboration. So there's a lot of research going into how humans, we had quite a bit about this in our paper. Sylvia knows about that because she contributed that stuff. And this human-AI collaboration calls for what's known as metacognitive skills. And so metacognitive skills are skills knowing about how we think, right? So for example, a metacognitive skill is awareness of what we know, what we don't know, reflecting on how we prompt and then adapting our results, and knowing how to ask. Knowing how to craft those prompts is a metacognitive skill. And then monitoring our own understanding and strategy use, so looking at what we're getting as we're prompting, that is also a metacognitive skill to be able to do that. By the way, folks, any teachers here, we need to be teaching our students these metacognitive skills because they're all using AI. And then regulating our own learning and our own problem solving, asking if we're over-relying on it, and asking, do we need to calibrate our level of trust with what it's giving. So I know Oscar Diaz showed prompt tech the other day. So that is an example of giving some of this support, right, and thinking about metacognition. So what kind of metacognitive skills do we need when we're thinking about using Gen AI as a collaborator, so it really augments our creative problem solving. Okay, I'm on to the last one, and just a couple of quick theories here. So collaboration, when we think about collaboration, when we think about software development, and you ask people, what is software? They usually answer, it's the code, right? Or they might answer, it's the executing program. I think, and others do, and Peter Nauer, even back in 1985, describes software not so much as the code or the executable, but software is a theory that we have in our brains, right, as developers, okay? So it's a construct. We have this theory of the program, And it lives in the minds of the people who work on it and use it. And this is really important because software is always changing. So the fact that developers are thinking about how it works, they're also thinking about how it can be changed to support future needs of the software. There's a really cool book called iPencil, which is basically about the fact that a pencil is quite a simple object. Would you agree? It's a fairly simple object. If you think that, read this book, you will change your mind. A pencil is very complicated, and the book goes into how it requires the knowledge of tens of thousands of people around the world to create the technology that goes into a pencil. And so when we think about something like Windows at Microsoft, which I've worked with quite a lot, that team, the knowledge, the distributed knowledge that goes into creating something like Windows goes far beyond Microsoft to the whole community. There are people that know about the different pieces. So the theory that I want to bring for collaboration here is called distributed cognition. Maybe some of you heard of this theory, again from human-computer interaction. And it's a theoretical framework that expands the boundary of cognitive processes beyond our cognition to think about how our cognition is spread across people, tools, and time. So remember I talked about Engelbart? Engelbart was actually, his ideas were the precursor really to distributed cognition because he realized that we do this cognitive offloading, right? And so what's important here is that it's not just in the minds of one developer and our understanding of the code, but it's across people. Ooh, I think I clicked too far. So cognition, Hutchins tells us, is social, right? Our decision making happens collaboratively. If you observe developers, even in a startup, it's not just one developer, they're part of a team, they're working with people. And their knowledge and their reasoning and the ideas that they have about how the program should be designed emerges from their human interactions with other humans. Okay? And it's also, their reasoning and their knowledge building also is temporal. So it's spread across multiple episodes of work. So if you want to really understand, I was talking about onboarding yesterday with, it's Margaret, right? Yeah. And so onboarding isn't just a set episode, it happens across multiple episodes of time. So if you want to understand that, you have to look at all of the people that are involved, but also look at it across time. And so examples of distributed cognition in software development, again, pre-Gen AI, we have lots of results looking at using this theory. Pair programming is an example of distributed cognition, two developers working together. Code reviews is an example of distributed cognition, and the use of design patterns as a way of communicating our knowledge about the architecture and design of the program is another form of distributed cognition. But my question is, I haven't found any papers yet that are looking at how generative AI is impacting collaboration through the lens of distributed cognition. In fact, there's very little so far on how generative AI is impacting collaboration and how people work together. So how is that going to impact the dynamics of team collaboration and how people understand? The second model, and this is the last one, I know I've given a lot of theories. I think actually I snuck in an extra one in the middle there. I'm not sure if some of you picked up on that. But this is the last one. This is the 3C model of collaboration, which again goes back to the early 90s and then was refined in 2008 to apply it to software development. And it thinks about collaboration according to these three concepts of communication, coordination, how we coordinate our work, and how we actually cooperate, how we share, right? And decide who's going to do what. And all of those three activities together foster our awareness, and in turn then, how much awareness we have mediates how effective we are at communicating, coordinating, and cooperating with others. So, if we have a misunderstanding about what time we're supposed to meet, that's because we haven't had good awareness about what I know and what I know somebody else knows. So this is, I'm just giving a very quick overview of this. It's a teaser to say if you're interested in collaboration, look at this theory and distributed cognition to do that. So there has been a study from GitHub that looks at how developers collaborate that I wanted to mention here.
because they noticed when they were looking at developers that developers work with on average 21 other engineers in a given week. That's a lot of people to collaborate with. And they spend 30% of their time talking to others, directly talking to others. And over half of them collaborate with other teams, at least once or more a week. So a lot of team interactions as well. And in fact, they say that collaboration is the multiplier for productivity and for developer experience. And in fact, many of them wanted collaboration. So there's a big focus in industry right now on metrics, on measuring productivity. Huge focus with generative AI coming along. They want to measure, they want these numbers, right, to say whether generative AI is actually improving productivity and experience. And so many want collaboration to be a top metric, especially in performance reviews. So there's some layoffs over the recent weeks at large tech companies, and they're complaining, look, yeah, maybe I didn't have so much code that I contributed to the code base, but I was helping these other people, on board. I was helping these other people do their job so that they could, move faster. So they want collaboration to be a top metric. And 4 out of 5 developers, according to this GitHub study, think that generative AI will make their teams more collaborative. That was the question they asked. Will generative AI make you more collaborative? Pretty high level question. So we need to dig into that and see what that means. So I just want to ask you, do you think the number of code reviews, so when you review somebody else's code, is that a good metric for collaboration? Is that a good way of measuring collaboration? Probably not. And which of the 3 C's does code review even measure? We don't know, right? So we still have a lot to do to figure out really how generative AI is impacting collaboration. And of course, as I mentioned already, collaboration is not just coding, so there's work going on looking at how Gen AI can also help building expertise and foster social connectivity in design teams. There's some work starting to come out of this. Oh, by the way, I will make my slides available as well. Sorry, I should have said that at the beginning. So which theories should we use or build to understand how Gen AI may shape these meetings that are essential to software development and build these social connections in software engineering? So you've been super patient. I went through all of the theories, and I'm just going to summarize by saying I looked at these 3 lenses to try to ask the question, what is it we know? These foundational human-centric theories in terms of our flow experience, our optimal experience, which honestly is essential to our happiness as human beings, and how tools augment our cognition, and as well as how tools support us in our collaboration and fostering community. And generative AI is, moving very fast, as I said, and we're looking beyond, the interface of chat, looking at how notebooks and other kinds of natural user interfaces are being used. And of course, if we're doing that, we've got to really sort of dig deep and understand what is it about these tools that expand our creative problem-solving capabilities. And so the reason I gave these theories, which I've summarized on the right here, is that these theories give us a conceptual framework to guide what to look for or measure. So as I mentioned, industry's moving fast and they're saying, oh, tool B is faster than tool A, but we don't know why, right? It could be that there was something really essential in tool A that they threw out because they didn't really understand what it was about tool B that was faster or better than tool A. It could be some accidental thing, right, that made tool B better. So it supports our explaining our results, it supports explanation and actionability, it allows us to do good comparisons across our tools and our studies, and it provides design guidance with the focus on humans, and it supports this critical reflection that I talked about. And so with that, remember how Google changed our minds? I talked about that, right? Like our minds are just not the same anymore. So just imagine our children from today, how generative AI's children will creatively problem solve tomorrow, right? Our children today are going to be developers of tomorrow because we're lowering the barriers to them creating code. And so with that, I'd like to close. Thank you for your attention as I went through these 3 different lenses to understand how Gen AI supports creative problem solving in software development. Thank you.